for joining this presentation, and I will try to share a concept about what I call this web of twins. So it's more an experimentation than an established project. So first, who am I? So I'm a software engineer, and I've been a long time a free open source software user, and I started to contribute like 20 years ago now. And I had the opportunity to join some industry and open source project like Tizen. I was doing some contribution for Intel at the time, and then I moved to Samsung to work more on IoT. And currently I'm open for any kind of cooperation or sponsorship, or I have to think about what can I am to do in the future. But anyway, first let me just introduce the concept of what is a digital twin. So in the year 2000, when I was a student, I hacked something which was very close to this concept, but I didn't know it. So I made some kind of a puppet you have in 3D in a VRML in the browser, and I was working with puppeteers. We have some kind of sensor, and we are trying to animate the puppet over the web. So it was a nice demonstration. There was no real market for this, but it was possible at that time. But it was not using any open source thing. So now the thing that changed, and I will explain why. So the concept itself has been well promoted by a researcher from Florida Institute of Technology, and he described as a digital replica of a physical entity. And the specific stuff is that both are somehow connected. So if you move the 3D model, for instance, it will have an effect on the real world object, and the same in the opposite way. So from this, you can have some kind of new service to design applications. So you can do some simulation, of course. You can use this at the design stage of the product of the device you are trying to consider, and you can try to think about what kind of API this thing can share to the others, and trying to establish new services even if you don't have the product. So it's part of the product life management, and it's quite interesting because it can when sometimes you have some delay due to production or sourcing, you can work on, let's say, the poor version of the device or the thing you want to work with. And it's quite popular now in the industry when people want to do some simulation of a production line and so on. Instead of building the whole thing, you can try to get some simulation and see how it behaves, and if you are configuring or altering a bit, you can get some early feedback without any cost. And then cities also is in the domain that can be useful, yeah. So before going on, I want to emphasize some ethical consideration, because large-scale deployment of digital twins can be problematic. Yeah, we have now many issues with social media, private information, private communication, and so on. So if we try to duplicate the world in the digital world, maybe we would try to have some ethical consideration from the beginning. So don't wait for problem to find solution. Maybe you just need to design your system and trying to avoid problems. So one thing interesting recently is that European regulation has a strong recommendation for system designer to handle privacy by design and by default. So I believe that it's an opportunity not to miss from open source communities, because privacy is part of our DNA. We are somehow users, so we know that everything should remain private when it's possible. So I think it's something where we can give us answers to this kind of future problem. So now let's talk about the web. It's designed for interoperability, that's for sure, and it's a huge achievement, because today we are still able to browse these websites that have been designed maybe 20 or 25 years ago, and it's transversal. You can connect everything to the web. So that's the base to do something. It has now really good 3D support. It was not the case when I made this puppet. You need to add some kind of plugins and so on. It was a bit boilerplate. Now you have a WebGL inside the browser. This means you have a good performance because it's working directly on the GPU. So making games in a browser is totally feasible. And yeah, privacy is one of the feature of the browser. So you have some kind of process isolation in the browser. So that's something interesting for the previous slide. And next, people in IoT and specifically the W3C, we are specifying the protocol and so on. They propose some recommendation to design IoT system without reinventing the wheel, but by adjusting existing standards. So we have like HTTP, JSON, JSON-LD, and WebSocket, and this kind of technology is still applied to IoT. And Mozilla made an implementation of this Web of Things concept, and the selling point of this project is making a home platform, a smart home platform, to give users control of their device. So they are handling privacy from the beginning of the project. So device and gateway are working together into user network. So there is no leakage possible, no data logging and so on. So the software itself is providing some UI to control all those things, to connect them together, to establish some behavior. And also you have extra features that you can connect to your home gateway remotely, share some resource one per one. If you select to share, let's say, a door to some members of your family, you can do this. And it has been designed to be flexible and to be support new plugins and new features. So that's the platform I've been working on. So web things now are dumb devices that are connecting to the gateway, but they are using a basic HTTP protocol, so it's based on REST. And they are describing all the resources using a Mozilla schema. It's a simplified version of what the W3C is doing, but basically it's the same. It's a set of properties to describe the thing. Is at a on button, I can turn it on and off, some level if I want to adjust the volume of the lamp of whatever, and some action if you want to give instruction to your device, like, okay, fade the brightness of your lamp slowly and then turn it off, for instance, and also receive some events from device. So, but if you want to implement simple things, you can just focus on properties. So security is handled by the gateway. So this means if you want to share the outside, this gateway is giving some REST API with tokens, so you don't have direct access to the device. You need to get authentified somehow. And yeah, that's it. So for instance, I made a very minimalist example. I call it a smart home example, but actually it has only one thing inside. This is just a solar panel on the top, so it's just a simulator. So you can try it, it's open source. And what you see on this description, you have some ID to identify and the properties as I just mentioned, and a link for each properties. And then you can put some, you can get the value or put the value using get or post request. It's straightforward. So now if we want to address the problem of visualizing the things, so I just mentioned about WebGL for the accelerated graphics, and now lately we have a new specification called WebXR, which is an evolution of WebVR we used to have a couple of years ago. I think it was showing just before, and now it's more unified and it supports an augmented reality use case. And to do some application, you can use the iframe framework, which is very, very simple. So 3D is not something, it used to be something really complicated, but now you can do this as easy as writing an HTML page in JavaScript. So here is a basic one. You just import the library and describe a a structure of different elements, and you combine with this. So here is a sphere inside it. So then something interesting is the GTLF format. So it's a format made for delivering 3D content to the web. It has been proposed by the Kronos group, who was in charge of OpenGL and other 3D formats. And it's basically just a structure in JSON describing the scene graph of each element of the content, and it's already supported in Blender 3D. So that's really interesting, because if you have to work with designer, probably they will not describe all their world by writing HTML5, HTML A-frame tags. They will use a tool. So here is an example with this GTLF output. So what you see in the background, maybe it's a bit dark, but there is a blinking piece on the roof on the right, which is simulating the value of my solar panel. So if there is a lot of sun, you get a higher value, and you can simulate this. And what I'm showing in this example is that you have a direct bindings between the description from the web thing, so the physical thing, the 3D, the actual device, and the same description is aligned to the GTLF format. So if I'm here, what I'm doing in this, I'm just updating the value. So if the value moves physically, like from a sensor, it will access to the DOM tree of the web page and change some attributes. Now, if you want to do something more physical, so something real, I made a DIY smart home of this size. So it's like a toy, and I made my solar panel with the garden lamp you can find for super cheap in the outside. You can just plug this directly to a microcontroller or board, and you get some basics of what a smart home with a solar panel will work. And it's running a JavaScript on the microcontroller. So you can then expose all the resources using the WebSync API for IoT.js, which is a tiny JavaScript runtime made for low-end microcontroller. And also I made also a module for dealing with sensors. So here is the demonstration, but I can try to make a live demo. So I'm just reloading. Connectivity is not that fast. I'm not sure it will work, but okay. So what you see on the corner here is a camera I have on top of my desk, and there is a small robot here. So I can control different units. So here is a light, for instance. So I can change the value. And the robot here is described from, so it's just a setup motor, and you can adjust different angles. So let me show you. It's running in real time. So what you see in the top is the actual thing, and below is a virtual one made with A-frame. It's not a one-to-one model. It's not the same because I made it by my own. And I found that it can be a bit challenging to have exactly the same system, because if there is some mechanical instruction, here I'm showing the rule system when you can change the attribute of the physical things depending on some context. And so here is the same rule in the opposite direction. So when I'm pressing on the on button, it will move forward, and if I'm turning it off, it will go backward. So as you can see, it's updated in the same time. It's not that there is no smooth animation. Oh yeah, I put a sensor on the head of my robot, and I'm measuring the color of what I see in front of me. So if I change the color of the light, yeah, it's updated in a sensor. So this is one use case. Also, I made a 3D version of my dashboard. So this is not the actual thing, this is just abstract widget in 3D, and it below it can interact exactly the same. So you can be in some kind of immersive world and interact with it, and it has the same effect in reality. So maybe it can be useless for many cases, but if you are considering you have a robot somewhere on some planet in space, and you want to control it, it's more maybe from an environment which is immersive, it's better. But more realistically, when you have very small mechanical parts that fit in a very restricted space, having the ability to scale it to larger level and to see and look around how does it behave can be also something interesting. Yeah. I think I have another demonstration here. Oh yeah, this one is about using sensor. Oh, but maybe I handle more questions later. So yeah, so what I have on the screen is it's a 3D scene, which is just a light bulb, and it's updating accordingly to what the sensor is showing. So it works in a browser, and browsers now are working in VR headsets. So you don't need to create a specific application. You can have something. So sorry for the quality of this video, but what I wanted to show is that I can make also standalone application. Here I made a link, and if you look at what I'm clicking, this is the address of my web sync, so I can get direct access to the sensor, and then it will update it in my 3D view. So it's VR now. I think, yeah, we made a version with AR at the same time. So yeah, the application is portable. You don't need to deploy it to a store. You don't need to under a specific SDK. That's the promise of the web. But that's the theory, because in practice, most of VR vendors are using extension and so on. So yeah, here I'm controlling some LED, and all the widgets I'm having action on are updated in a VR world also. So what am I doing here is, okay, turning on a fan. Yeah, it's off. And I think, yeah, I have also a smart outlet. Here is a switch, so I can. So it's the same switch we have in the dashboard can be also integrated for the 3D world, and it's having an effect in the same time. So yeah. So the beauty of this demonstration is that I use the Mozilla schemas, and it's generic enough to describe all kinds of things. You don't need to have to do something specific. If you have to deal with Boolean numbers and so on, it will work for a wide range of devices. So yeah, the same in 3D here. So yeah, if there is any question, I would be happy to give any hints.
So I'm sure there will be questions, because not everything was self-evident, especially when you discover all the possibilities. So we'll start with the first question, rather.
By the way, you forgot your laptop. Yeah, okay, you get it. I think, yeah. There's another demonstration I can show. It's only a minute. So yeah, I made this robot, and so first I made a web sync of just a motor, a servo motor, where I can adjust the angles, and I was updating a AR frame. So as soon as I had this working, it was straightforward to animate a real robot with 4 motors. It works for 1, it works for 4. So here is a 3D version of it where you can look around it, as I said previously. So anyway, it's a proof of concept so far. I made it very modular, so if you want to build things, you can just pick some specific component and you can build something else. And all is open source, so I need to share you the links.
Okay, I was just wondering which part was the most challenging one, the most challenging part of the project.
Okay, thanks. So you said what was the most challenging part of
Yeah,
this?
yes.
Okay. I would say that to identify the right person to introduce me to this kind of technology. So this story started actually 1 year ago in this room when we met together, and we had some kind of different approach of something common, and we met again in my home city, Rennes in France, and we started to act together something, and in the less than a day we established the both way direction from sensor to really to 3D and back and forth. So we got pretty fast results, that's for sure. And to answer the question, no major difficulties, but when you are dealing with IoT device, it's not very reliable, for instance. So this robot is made for, it's like a toy actually. You can buy it for a couple of euros, and sometimes it gets stuck and so on. But for prototyping, it's not a problem. It's not something you're running in production. So if you want to build something real, like physical device, yeah, reliability of the device is it's a full-time job. Yeah. Here it's a research and development project. Yeah.
Do you have any plans to use other robots that are low-cost robots, but a little bit, better than?
Yeah. Yeah. So the question is, if I have any plans to use a different range of robots. I'm not specifically a geek of robots. I wanted to make at least once, but I figured it out that the robotic community now in open source is quite interesting. Now they are making a lot of open hardware device you can get, but yeah, does it worth the investment? For me, not specifically. But if there is those projects, if they're looking a software stack to use, that's probably yeah, I will be more than happy for them to use this. Yeah. But again, if you go into robotics, probably JavaScript is not the best option here, because you have a lot of hard real-time constraints. So I'm not sure it's part of the standard yet. So the most important platform, for instance, is ROS, the robotic operating system. But for here, it's not critical, because it's just an arm. It's not going to break anything. But if you are making like a RC car or something like this, yeah, if you break too late, you can destroy it.
Right.
Okay.
Can you clarify the purpose of each tools you use? Like, I don't understand what the Samsung tools does and what the Mozilla tools does too.
Okay, so let's start from the lower level. So first, we need a hardware platform. Okay, the question is, what is where are the tools are interacting between each other, and what is specific to Mozilla and other components. So once you have this hardware setup, you need to implement this Mozilla REST API. So it's not a software; it's mostly a protocol. So you can do in any tools you want. For me, I ported a Node.js library to IoT.js, which is a JavaScript runtime from Samsung. So yeah, in this case, I am in both world. And then once you have this REST API from the thing, yeah, you need to connect to the gateway for sure. And then if you want to get access to the thing directly, if you want to do it properly, you need to share the resource through the gateway to another device that will understand the REST API. So this API can be implemented in any different languages. So I made my JavaScript code, it's just a client. And then from the rendering, I reuse another project which was initiated by Mozilla, but it's now living by its own, which is the A-Frame framework. And this framework is based on the standard I mentioned about WebXR, which is standardized by another group. So the full chain is different pieces of open source. Each is smoothly working together because they are aligned to a fixed specification. So doing some quick and dirty acts is something interesting, but to achieve some cooperation, and if you don't want to lose time to do some bridge from one technology to another, it's better to use the same all the chain. Nobody is speaking after, so I can stay here the one year.
No.
No, there's
We'll
course.
have to give up the room. What's the ideal contribution you would get on those repositories?
Something unexpected.
Good, because we have a creative crowd. So.
No, something I think that could be interesting is to geolocalize different objects and having them working together. So maybe either at a human level or maybe something bigger like a city, let's say, visualizing traffic jams and so on in real time. That's something can be nice to see. But yeah, no, I have no specific ideas. I just wanted to validate that this can be done, so then it can apply to many use cases. Yeah, if you have some hints about how do you create a web framework that interact with in real time with a lot of different sources, that can be interesting. Because here it's easy because I have only one device and maybe a couple of a dozen. But if I want to scale to maybe 1,000, maybe it's not the best way to do it. So I have to maybe use a different protocol. Yeah, I know that there is some streamable like time series and so on. So maybe it's something I should look at.